Rogue waves, also known as freak waves or monster waves, are massive, unexpected ocean waves that can appear suddenly and pose a serious danger to ships and offshore structures. For centuries, sailors told stories of waves so large that they seemed almost mythical. But modern science has confirmed that rogue waves are real, and researchers are now uncovering the mechanisms behind their formation. Rogue waves are unusually large and unpredictable ocean waves that are at least twice the height of the surrounding waves. Unlike tsunamis, which are caused by underwater earthquakes or landslides, rogue waves form without seismic activity and can appear in deep open waters. Key characteristics of rogue waves: sudden and unpredictable. They appear without warning. Short-lived, they last only for a few moments before disappearing. Steep and deep troughs. They have very steep sides and deep valleys. Extreme height. Some rogue waves exceed 25 meters or 82 feet in height. For centuries, rogue waves were thought to be sailors' myths or exaggerated sea stories. Some legends include the Kraken's wrath. Ancient sailors believed that giant sea creatures like the Kraken created massive waves to sink ships. The perfect storm waves, fictionalized in books and movies, rogue waves were thought to be just a rare combination of normal waves, supernatural or divine punishment. Some cultures believed rogue waves were omens or divine retribution. It wasn't until 1995, when the Draupner wave, a 25.6-meter rogue wave, was recorded on an oil platform in the North Sea, that scientific evidence confirmed their existence. Scientists have identified several mechanisms that can lead to rogue wave formation. A. Linear superposition, constructive interference. Normally, ocean waves travel in different directions with varying heights. Sometimes multiple waves meet at the same time and combine their energies, creating one massive wave. This is called constructive interference and can amplify wave height significantly. Nonlinear effects, wave energy focusing. The nonlinear Schrödinger equation describes how energy moves between ocean waves. Under certain conditions, energy can concentrate into a single wave, making it grow exponentially. This is known as the modulational instability, which can lead to rogue waves. See ocean currents and wind effects. When powerful ocean currents oppose the wind and waves, they can force waves to grow steeper and taller. The Agulhas current off the coast of South Africa is a well-known region for rogue waves due to this effect. D. Group velocity dispersion. When slower, longer waves catch up to faster, shorter waves, they can merge into a massive wave. This process causes waves to concentrate into one large rogue wave rather than spreading out. Several documented rogue wave incidents have caused significant damage. Draupner wave, 1995 in the North Sea, was the first scientifically measured rogue wave at 25.6 meters. Queen Mary, 1942 in the North Atlantic, faced a 28-meter wave that nearly capsized the British ocean liner. Louis Majesty, 2010 in the Mediterranean Sea, saw a rogue wave kill 2 passengers when it smashed into the cruise ship's windows. Predicting rogue waves is extremely difficult due to their sudden and random nature. However, researchers use mathematical models based on nonlinear wave theory, satellite observations to track wave patterns, and wave monitoring buoys to detect unusual wave formations. Although prediction remains challenging, advancements in wave physics are improving our understanding of rogue wave formation. For ships and offshore platforms, safety measures include better ship design to withstand extreme waves, real-time wave monitoring for early detection, and improved weather forecasting to avoid high-risk areas. Rogue waves are a fascinating and dangerous natural phenomenon that science is still working to fully understand. Once dismissed as sailors' myths, they are now recognized as real threats to marine safety. As research continues, we may develop better prediction models to safeguard ships and offshore operations from these oceanic giants.